Now let's talk about geometric sequences and series. Let's start with a sequence. So sequence meant that we are simply listing the numbers, but they have in geometric series a rule where we either multiply or divide with a value to go from one value to the next. And in the example that we have here, 3, 6, 12, 24, the rule was to always multiply by value 2 to go from one value to the next. Now, if we have a similar approach that we start studying the values. The first value is 3. Obviously, once again, it has to be given. Second one you get by multiplying with 2. That is how you get to the second value. Third one is obviously the second one multiplied by 2, but now we can replace the number 6 with where did number 6 come from. So 3 times 2 is the 6, and then that is multiplied again by value 2. And let's continue to do the same with the fourth one. So value 12 is multiplied by 2, and where did the number 12 come from? From this list of values. So it is 3 times 2 times 2 times 2. And now if we study this in detail, how could we write this mathematically shorter? Obviously the first one is simply 3. Second one is still the same 3 times 2, but here where we have 2 times the same multiplier, we can use of course exponent to write it. So we say 3 times 2 to the power of 2. Next one, here we are multiplying with the value 2, so we say obviously that the multiplier 2 is to the power of 3. Alright, now we have an idea how to work with geometric sequences. Now, what if we are asked for the 10th value in the same sequence? Well, we already had an idea how to work with the values, and now notice a similar trend that we always have the first one, the same one. We are always multiplying, now multiplying in a geometric one, not adding as in arithmetic. So multiplying with the common ratio, and the exponent 1 is in the first one, even though we don't usually write it, but it's there. So in the first one, there's no exponent. Second one to the power of 1, third one to the power of 2, fourth one to the power of 3. So obviously if we want to go to the 10th one, we say 3 times 2 to the power of 9. So the exponent is 1 smaller than to which value we want to go to. In our case it would be 1536. And we can still write that in a formula. So, oops, there's a mistake in my slide. So this should be of course geometric sequence, not arithmetic. I will fix that later on. So we have the first one multiplied with the Q letter is used for the common ratio. The letter Q is coming from the word quotient. That is the name mathematically for dividing two values. But usually it's referred to as the common ratio. So to the power of n minus 1. Lastly, the geometric series. However, it's not very easy to deduce the formula for that, like it was in the arithmetic. So therefore, with the geometric series, I will give you the formula. Feel free to find out from some math book or Google it how to derive the formula if you're interested. As our focus is more on applying this correctly in business math related cases, we are not focusing on the how to derive the formula. The formula is like this. And S is for the sum, so series was always calculating a sum. So that is why it's S value here. And notice, we only need to know the first one in order to calculate the sum. So we don't need to know anything else than the first one. And also important thing to notice that in this formula, the exponent is n, not n minus 1. The minus 1 is outside this exponent. Lastly, remember, if you're using a calculator to do this, you need brackets over the both the divider and the dividend. So both of these need to have brackets over them when you do the math. Now let's apply this formula for the case that we had. So the sum, 3 is the first one. The Q value, the common ratio, that is the same as the multiplier, was number 2. How many values did we have? We had, this one was the 10th one, so we know that to the power of 10. And then we do the math with a calculator.